Hi, this is Sahil. So this is the second part of our icon tutorial. Before we start that, I just wanted to clarify something. In the first part, you can see that I'm using mouse move event just to track the position of the mouse, and then I'm using this mouse object to do all the calculations like angle, etc. Uh, we can do all these calculations inside the mouse move event itself, but problem with that is the mouse move event gets fired too many times every second. So to avoid that, we can, and to get best performance, we use either the request frame animation function or GSAP stick event. And there are some other benefits that I'm going to talk about at the end of the video. So let's get started. First of all, we have you can see that I have just similar setup, and first of all we will define our prototype, which is going to be var plus equals to function, and then we are going to define some of the properties like this dot x equals to 0, this dot y is going to be 0. Everything is just going to be at the default positions, not a the left and top properties, we are going to use them to give fixed position to our icons. Then this dot width, and finally this dot scale. I'm just defining it right now, but we are going to use it in the later part of the video. The scale is going to be 1 by default. And then we are going to add a draw method to our prototype. To do that, we are going to write plus dot prototype dot draw, and then we are going to assign a function to it. So the draw function is going to be slightly different from my original demo. In the draw function, I'm just going to draw the plus icon. So move.to equal to 0 comma negative this dot height by 2, and context dot move to line to 0 comma this dot height by 2. Then the first one is for the vertical line, and then context dot move to negative this dot width divided by 2 comma 0, and context line to this dot width by 2 comma 0. And then I'm going to select our canvas element, which is going to be var c equals to document.get element by id. And then context, which is going to be c.get context. And then I'm going to define the science variable, which is going to be array, which we will use to store our objects, and then mouse object, which we will use to track the position of the mouse. And finally the grid length, which is going to be 9, so we will use it to create the 9 by 9th grid. And now we are going to create 2 for loops to create our grid. So our first loop is going to be a for loop while I is less than grid length I plus plus, and we are going to use our first loop just to define our 2D array. So since I is going to be an empty array, sorry, and then I'm going to define another loop. So the first loop is going to get executed 9 times, and the second loop inside it is going to get executed 9 times every single time. And then I'm going to create new variable sign just to keep things organized, and I'm going to assign our new instance of plus icon to it, and then I'm going to define some of the properties. Sign dot left is going to be canvas dot width divided by grid length, and I'm going to leave some of the calculations here as it is, and I'm going to explain them later and change them when I'm going to draw, just to show you what's going on. And sign dot width is going to be, let's say, 10 pixels. Sign dot height is going to be 10 pixels. And now I'm going to assign our sign variable to our array. So it is like pushing our new object inside the array. And now I'm going to define our ticker event. And inside this draw function, we are going to loop through in exactly same fashion. So we are going to use 2 for loops, nested for loops. And just note that the first loop is being used to define our objects, so it is going to be slightly different, and the second loop I'm just using to access the values or access the objects. And again I'm going to create new variable just to keep things organized, and I'm going to assign each object to the sign variable. Then sign.draw, and I'm going to pass the context to it. And at the end of the loop, I'm going to call the context.stroke method. And you can see that all icons are being drawn in the top left corner. So now I'm going to set the transform to each object. So we can do that by context.set transform. The first parameter is for scale x, which is going to be this dot scale, and second and third parameter is for skew x and skew y, which is going to be 0. Fourth parameter is for scale y, so which is going to be scale, this dot scale, and fifth and sixth parameter is for x and y transform. So our x transform is going to be this dot left plus this dot x, and our y transform is going to be this dot top plus this dot y. And now you can see that our icons are being drawn, but they are being drawn in the same position. That's because we have just divided we have assigned the left and top position to each element by dividing width and height by grid length. So now I'm going to multiply the left property with I, and you can see that all the icons are being drawn horizontally. And then I'm going to multiply top with J, and this will make our icons being drawn vertically. And now you can see that the first icon is at the border. So to fix that, we will do the I plus 1 and J plus 1, and you can see that our last icon is at the border. So to fix that, we are going to divide our canvas dot width by grid length plus 1. So this is going to add another column and another row to our grid. And now you can see that all our icons are being drawn in the center in 9 by 9 grid. And next I'm going to make change to our draw function, and I'm going to write context dot begin path and context dot close path, just to create one single path on each loop. And then now I'm going to create our mouse movement. Say dot add event, and inside mouse movement I'm going to just calculate the position of the mouse. So mouse.x is going to be e.clientx minus rect.left, and mouse.y is going to be e.clienty minus rect.top. And then we are going to use these mouse coordinates to animate our icons. So before our draw loop to draw our icons, I'm going to calculate the position of the mouse with respect to each icon, and I'm going to loop through to add the animation. So to do that, I'm just going to define a function and call it here. So now I'm going to define our function calculate icon position, and first of all I'm going to loop through each of our icon by using the signs array. And every time the loop is going to be same. And first of all, I'm going to define the sign variable, and assign our object from the array to it, just to keep things simple. And let's say our radius is going to be 20 pixels, and then we have to calculate the angle between mouse and our icon. So dx is going to be mouse.x minus sign.left, and dy is going to be mouse.y minus sin.top, and then we are going to use this to calculate the angle between mouse and our each icon. So angle is going to be math.atan2, and first we will pass the dy and then we will pass the dx. This will give us our angle, and then we can use our twin max twin. Duration is going to be 0.3 seconds, and then x is going to be math.cos, and then we will pass our angle, and then we will multiply it with our radius, and y is going to be math.sin, and then we will pass our angle and multiply it with radius. And you can see our icons are animating, but we will have to make some changes to our draw function. And right here I'm going to call context.clearRect c dot 0, 0, comma c dot left, c dot width, comma c dot height, and this will clear our canvas on every single view. Okay, we will have to save and restore our context as well. So to do that, I'm going to call context.save before beginning of the loop, and at the end of the loop I'm going to call context.restore. Now you can see that our icons are being animated. But now you will see that if I move my mouse around, you will see that all these icons are going in circles around the around the mouse. So to change that, I'm going to make some changes to our calculate icon position function. So first of all, I'm going to calculate the distance. So to calculate the distance, I'm going to write math.sqrt. Inside the function, I'm going to multiply dx into dx plus dy into dy, and this will calculate the distance between our icon and the mouse. And if in case this distance is 0, we are going to assign the distance as 1, just to avoid any not a number calculations. So next I'm going to write the if loop. If distance is less than radius, then radius is going to be equals to distance. And now you can see that if I move my mouse around, any icon that is close to the mouse, it will follow the mouse. So next I'm going to write another twin here, and it is going to be for our scaling. Duration is going to be 0.3 seconds, and we will change our scale to 2, and if the statement is false, then we will change our scale back to 1. And now you can see that any icon that is near the mouse, it gets scaled up. And finally I'm going to add another variable that we are going to use to keep track if mouse has moved. Initial value is going to be false, and I'm going to set mouse mode is equals to true every time our mouse moves. And here, if mouse has moved, I'm going to only then I'm going to call this function, and after that I'm going to set mouse mode is equals to false. So this will limit all the calls to these twins, so these twins will not get executed unnecessarily if our mouse hasn't moved. And now you can see if I mouse out, our icons are staying in their position. So I'm going to add another another event listener. And again I'm going to loop through all the variables just using same loop. And again I'm going to assign our object to science variable. Okay, there is typo. And now I'm going to call twinmax.to. Sine duration is going to be 0.3 seconds, and we are going to say reset our x back to 0, y back to 0, and scale is going to be 1. And now you can see if I move my mouse at some certain times, the elements are still being not animated back to their original position. So to avoid that, I'm going to define another variable mouse over that is going to keep track if our mouse is over the canvas. So I'm going to add another event listener, say dot mouse enter, and here I'm going to set mouse over is equals to true, and here I'm going to set it back to mouse over is equals to false, and here I'm going to change our condition only execute if mouse is over and mouse has moved. So now if I move my mouse out, this function is not going to get called at any cost, and this twin can complete and we can reset our grid. So this video has gotten really long and I'm not sure if I should post the third part, but let me know if you want to learn the entire demo. There are some really minor calculations that are necessary for bells and whistles to just complete your demo, but this video is already 24 minutes long and I'm not sure if I should post the third part. So now, as I said, the benefit of defining the mouse object to track the mouse position, what you can do is you can just use this demo as it is and remove all the mouse events, and you can use it to create some kind of some effect like this where you will animate the mouse object, and you can use that to animate your grid icon however you want. So that's all. Let me know what you think, if I should post the third part, and let me know if you want to learn anything new. That's all. Thanks for watching.